sketch the graph of f of x equal to 2 minus e to the 2x minus 1. To start off, I want to sketch my base function, which is e to the x. So remember, for e to the x, there are 4 things you need to memorize. Where the horizontal asymptote goes, that's going to be the x-axis, y equals 0. And then 3 points. The points where I put in 1, 0, or minus 1 into the function. E to the 1 is e, which is roughly 2.7. So we go over 1 up 2.7. E to the 0 is 1, so that's going to be the y-intercept. And then e to the minus 1 is 1 over e. If you call e 3, which is a rough guess, then this is roughly a third. So that's going to be minus 1 up a third. Connect the dots, and as we let x go out to infinity, the values here go off to infinity also. So this is our graph of e to the x. We're going to build everything else off of this. Let's take a look at our procedure. We want to work from the inside out. This would mean if you gave me a number and asked me to compute the value from this, we're going to have to go through a whole bunch of steps. So the very first thing I would need to do is figure out what e to the 2x minus 1 is. Then I'd have to multiply by a minus 1, and then I'd have to add 2 to that. So that's the idea. We're going to do each of those operations, starting from the inside, working our way out to the adding 2. Let's take a look at e to the 2x minus 1. So the idea is I want to rig this so that I'm picking off the good values for e to the x, that being 1, 0, and minus 1. The problem is I can't just stick in these numbers for x. Whatever I stick in has to go through 2x minus 1 first. So the idea is to work backwards. We start with a good value, 1, 0, or minus 1, and call that 2x minus 1. Then we can solve for the x, and that x is guaranteed to give us back the e1 or e to the minus 1 that we want. So now you just solve the equation, say 2x minus 1 equals 1. The 1 comes over, we divide by 2. So the x that produces the e is going to be the 1. We do the same thing for 0, gives me a half. Do the same thing for minus 1, that gives me a 0. So I now have 3 points, 1e, so go over 1, up e. I have a half 1, go over a half, up 1, and then 0, e to the minus 1, so that's going to be 0, and then up a third. Our horizontal asymptote's not going to change at all from this. This operation is only dealing with pushing around x values, so everything above the x-axis will stay above the x-axis. We connect our dots, and then we get this here. Geometrically, what's happening? If you rewrite the 2x minus 1 as 2 times x minus a half, if you remember, when we have things on the inside, they behave the opposite of what you would think. So in this case, the x minus a half means shift to the right by a half. Okay, you can see that the dot over 0, so our 0, 1, is just going to shift over to 1 half up 1, just like we would expect from our shifting to the right by a half. Okay, next, we're going to have a squeeze. Well, you would think you would want to stretch by 2 if you multiplied by 2 on the inside, but you do the opposite. So that's going to squish in by a half, or squish in by a factor of 2. So that's going to mean, the way we see this, remember, the distance from the 2 points on the end is going to go from minus 1 to 1, so that length is 2. Going from the points on the end now is going to go from 0 to 1, so that's going to have length 1. So we're going from length 2 to length 1. So we're doing some squeezing here. Okay, anyway, that's what I get for e to the 2x minus 1. Notice, once we're figured out what this is, everything else is happening to y values. So we're going to do this in 2 steps. Now my new 3 points are going to be these. These are the 3 we got from the e to the 2x minus 1. So now I'm just going to multiply by minus 1, so that's just changing the y values. So we multiply each of those by a minus sign in this column. Okay, the net effect is just to flip from the top to the bottom. Note that the horizontal asymptote won't change because if I switch y with minus y, well, 0 goes to minus 0, stays at 0, so the horizontal asymptote stays where it is. Okay, then we plot our 3 points and we just see that they go underneath, like we would think. Now all we have to do is just add 2 to the y values, and that'll give us our graph. So let's see what happens. The horizontal asymptote, we're at y equals 0. That's going to go to y equals 2. So we just move that up by 2. We have our 3 points. I'm going to add 2 to each y value, so it's going to give me 2 minus e, which is roughly minus 0.7. That point is over 1, down 0.7 right there. Our next point is going to go to a half, comma 1. So we're going to go over a half, up 1. And then my last point, 0, 2 minus e to the minus 1, which is roughly 1.7. So we go up to here. Asymptote stays where it is. At y equals 2, we connect the dots, and that gives me my graph of the final function.